Hello and welcome to the new series of lectures based on digital electronics. Now here we are going to discuss about the fundamentals of digital electronics for basic electronics only. So it is not a higher semester course of digital electronics where it is discussed much more in detail. Here we will be confining our discussion to basic Boolean algebra, basic logic gates and simplification of logic operations. So let us try to understand the concept of logic 0 and logic 1. In our earlier discussion of transistor series, we have seen the maximum voltage applied to a transistor is VCC and the minimum is the ground level, that is zero potential. So zero potential is equated to logic 0 and VCC is equated to logic 1. Now question arises, if the signal lies in between 0 and VCC, then how it will be equated to either 0 or 1. So for that we need to have the concept of the threshold limit. And earlier we have seen that a transistor goes to the on state when we have VBE equal to 0.7 or more for silicon transistor, and it should be 0.3 volt or more for the germanium transistor. Output characteristics of the transistor shows that we have different regions of operation. So cutoff region, saturation region. So basically transistor, when it uses as a switch, then it is switching between the on state and off state, saturation and cutoff region. So when transistor is at the cutoff region, we equate it to 0, and whenever it is above the cutoff region, then we equate to 1. So that is the basic concept of logic 0 and logic 1. Our entire digital electronics and all the digital systems, starting from the computer, mobile, television or any other kind of digital devices, are completely based on this concept. Now the concept of Boolean algebra. Now since we have only two states, 0 and 1, so how these 0 and 1 are being used in digital circuit, that is defined by Boolean algebra. So in Boolean algebra, the variables of equation can take only two values, that is 0 and 1, and thus irrespective of how many variables are involved, so maximum value can be 1, minimum value can be 0. So any number of variables we may have, but all the variables can have only two values, 0 and 1. Now in Boolean algebra, basically we have two kind of operation: Boolean addition. Now Boolean addition says 0 plus 0 we get 0, 0 plus 1 we get 1, 1 plus 0 is 1, and 1 plus 1 is also 1. Similarly, we have Boolean multiplication. Now in Boolean multiplication, we get 0 dot 0, that is equal to 0, 0 dot 1 is 0, 1 dot 0 is also 0, and 1 dot 1 is giving us 1. Now this Boolean addition for logic operations, it is popularly known as OR operation, and Boolean multiplication is considered as AND operation. Other than OR operation and AND operation, there is another operation which is called complement. So complement is nothing but inverting. So if we want to invert 1, we'll get 0, and similarly if we invert 0, we'll get 1. So this is popularly known as NOT operation or inverting operation. Now Boolean operations, these are implemented through the digital circuits. So entire digital electronics and today's modern devices, starting from your mobile phone, television, your internet, computer, all are digital devices, and all of these digital devices are having number of logic gates. So what are these logic gates and why these are used? So Boolean operations are implemented. Boolean operations are operations are implemented through digital circuits. Now these digital circuits are what? These digital circuits are known as logic gates. So logic gates are the digital circuits and with one or more input. So a logic gate can have a single input or it can have multiple input. Now these logic gates, depending on the basic Boolean operations, we can have three different types of logic gates. So these are called basic gates. Basic gates. So basic gate, first one is called as NOT gate. So this is called the NOT gate, and it is having only one input and one output. So if we have the input variable as A, at the output I'll get the variable A bar. So complement of A. So earlier we have seen this inverting operation. So this is called NOT gate. Now other than this, all other gates are having at least two inputs. So this is called AND gate. So AND gate is taking two inputs. This is performing AND operation, that means Boolean multiplication operation. So it will have two inputs, say A and B, and output is A dot B. So all these outputs will be getting over here, and we have another gate which is called OR gate. So this is the symbol of OR gate. This is also taking two inputs, say A and B, and giving output say C. So C is equal to A or B. So this plus symbol for logic operation, it is read as A or B. So here A or B is performing all these Boolean addition operations. So these are about the concept of basic logic gates. Now in next lecture we'll be elaborating our discussion on the logic gates. So here we end this lecture. Thank you for joining, and join me for the next lecture on digital electronics series. Thank you.